Hello everyone. Today we are going to look at a quick and easy visual guide to Class 9 Mathematics Chapter 2, Logarithms. In this video, we will break down scientific notation, common and natural logs, and the laws of logarithms in the simplest way possible. Let's get started. So what actually is a logarithm? Simply put, it answers one basic question. To what power must I raise a base to get my target number? For example, in exponential form, we write 2 cubed equals 8, meaning 2 multiplied by itself 3 times gives us 8. If we write this exact same relationship in logarithmic form, it looks like this. Log base 2 of 8 equals 3. This reads as, what power of 2 gives us 8? The answer is 3. Think of these as two different ways of saying the exact same thing, just like looking at two sides of a mirror. Once you master converting between them, this entire chapter becomes a breeze. Next up is scientific notation. This is just a smart and simple way to write extremely large or extremely small numbers. The standard formula is a times 10 to the power of n. Here, our coefficient a must always be a number between 1 and 10, and n is an integer. If we have a huge number like 78 million, we move the decimal point to the left, which gives us a positive power, 7.8 times 10 to the 7th power. But if we have a tiny number like 0.00000000315, we move the decimal to the right, resulting in a negative power, 3.15 times 10 to the power of minus 8. Be careful to avoid a common mistake. Writing 78 times 10 to the power of 6 is not proper scientific notation because 78 is larger than 10. Always make sure a is less than 10, so write it as 7.8 times 10 to the power of 7. Now let's understand the general definition of a logarithm. The expression log base b of x equals y means b to the power of y equals x. There are three key parts here. First, we have b, the base. This is our starting block that gets multiplied repeatedly. Second, we have x, the argument or result. This is our target number. And third, we have y, the exponent or logarithm. This tells us how many steps or powers we need to reach our target. Just remember three golden rules. The base b must always be greater than 0. It can never equal 1. And the argument x must always be positive. A common logarithm is simply a log with a base of 10. In writing, we usually just write it as log of x without showing the base. Every common log has two distinct parts, the characteristic and the mantissa. The characteristic is the whole number part before the decimal point, and it represents the scale or size of the number. A quick shortcut to find it is to write the number in scientific notation. The power of 10 is your characteristic. The mantissa is the decimal part. It is always positive, and we find its value using a log table. For example, in log of 13.45 equals 1.1287, the characteristic is 1, and the mantissa is 0.1287. An antilogarithm is just the reverse process. If you are given the result of a log and need to find the original number, you take the antilog. We can do this in 4 simple steps. Step 1. Separate the characteristic and the mantissa. Step 2. Look up the mantissa value in the antilog table. Step 3. Add the mean difference from the table. Step 4. Place the decimal point in the final answer based on your characteristic. For instance, if we find the antilog of 2.1245, our final answer will be 133.2. Logarithms generally come in two main types, common logs and natural logs. Common logs use a base of 10 and are widely used for everyday calculations and general science. Natural logs, on the other hand, use the mathematical constant e as their base, where e is approximately 2.71828. We write natural logs as natural log of x, and they are highly important in advanced mathematics and calculus. And here are 2 quick facts to keep in mind. The log of 1 is always 0, and the log of 0 is completely undefined. These are the most powerful tools in this chapter. The laws of logarithms. Make sure to memorize these 4 rules. First is the product law. When two numbers are multiplied inside a log, we can split them by adding their individual logs. Log base b of xy equals log base b of x plus log base b of y. Second is the quotient law. When numbers are divided, we split them by subtracting the logs. Log base b of x over y equals log base b of x minus log base b of y. Third is the power law. If the argument has an exponent, that power jumps right to the front of the log. Log base b of x to the power of n equals n times log base b of x. And finally, we have the change of base law, which allows us to convert a log to any new base we need. Have you ever wondered where we actually use logarithms in the real world? We use them to measure the loudness of sound in decibels, to calculate the intensity of earthquakes on the Richter scale, and to project compound interest and financial growth over time. Logarithms are incredible because they turn massive, complex calculations into simple, manageable addition and subtraction. To score top marks in your exams, make sure to avoid these 5 common mistakes. When writing scientific notation, always make sure your coefficient a is strictly between 1 and 10. Never write a negative mantissa, always use bar notation for negative characteristics instead. Double-check your decimal movements so you don't mix up positive and negative powers. Don't misapply the product and quotient laws. They apply to single logs of products or quotients, not to separate logs multiplied together. And most importantly, always remember that you cannot take the logarithm of a negative number or 0. Let's do a quick recap. The absolute core formula of this entire chapter is log base b of x equals y if and only if b to the power of y equals x. Every other law, rule, and step we've learned builds directly on this fundamental relationship. Once you understand how to switch between exponential and logarithmic forms, you can solve any problem in this chapter. I hope this visual guide helps you master logarithms. Good luck with your studies and see you in the next lesson.